Yes.
You have said you don't hold any on-limitation, and you also said you delete all versions on commit.
Yes.
So how do you handle read consistency?
Okay, so the question is, if I delete old versions on commit, how do I handle read consistency? So I glossed over that detail. That's the sweeper. So the sweeper, I said the sweeper waits until a transaction is committed or rolled back and then it can do its job. Actually, it's got to wait a little bit longer than that. Yeah? Thank you for paying attention. It's got to wait until all transactions that were started during the life of that transaction to end as well before it can sweep a transaction. Okay, question at the... Do you have a question? No. Okay. Sold to the man at the back. Yeah, Lance.
What is the index type that you currently support? How is it structured? And do you plan on supporting R-tree indexes at some point? Okay.
Question is, what type of index structures do I support, and am I planning to support any other types like R-tree or whatever? Okay, so that's an interesting question. I think one of my graphics might help us there. Yeah, I think the first one. Okay, this is just a standard B-tree index without any prefix compression. It's got one innovation in it. I'm very lazy on delete in the index. I don't merge index nodes immediately on delete. I wait for them to actually be cleaned out completely. Because the thing about merging them is that you often then, fill them again anyway, and then that was like a waste of work. So those are standard, otherwise standard B-tree indexes. Now the thing about this is that this system, as I said, I've decoupled the writing of the index from the writing and of the rest of the database. So when I'm committing a transaction here, I'm not worried about at what state the index in is, if it matches the transaction or not. Only thing I'm worried about is that when I do write the index file, that I write it consistently so that it's not corrupted in any way. But it might have entries that are point to rollback transactions, and it might have entries, and it might not have entries that it should have on recovery. And the advantage of this system is that because it's decoupled, I can actually plug in a different type of indexing system which wasn't designed to run in a transactional system. I don't know about R-tree or anything else, but if I get an algorithm, it simplifies the writing of another index for the system, because, as I say, it doesn't have to be transactional. It just has to be able to keep consistent. It doesn't have to guarantee that the right entries are in there when the transaction is committed and so on. It just has to guarantee that it remains consistent. And that's quite common if you've got a full-text indexing system. People write great full-text indexing systems, and they can write them consistently to disk. But writing a full-text index and keeping it transactionally consistent is another step more difficult. So I can actually integrate, I think, other types of indexes easier than, or let's say, existing indexes which are being written for other systems easier than perhaps another storage engine.
So do you store varchar index data on index files or just pointers?
Do I store?
Varchar data in the index files?
Do I store varchar data in the index file or just pointers? No, I stored varchar data in the index files. There's a limit of about 1 or 2K of the size of an individual column in the index time. Okay, yeah. Thanks for your participation. We managed to fill the rest of that time pretty well with the questions. Okay, that's great.